In this video, we'll look at an application of quadratic functions related to area. We have that 300 feet of fencing is available to enclose a rectangular yard alongside of a river, which is one side of the rectangle as shown. What is the maximum area that can be enclosed? Well, the thing that we don't know are the length and width of this rectangular yard. And so we're going to denote variables to represent the length and the width. So we'll let L be the side opposite from the river, and the width are the sides perpendicular to the river. We know that we have 300 feet of fencing, so that means the perimeter of this enclosed area where we're putting the fence, we're just using the 300 feet for fencing, is going to be 300. So we would have L plus 2W is equal to 300. Now we are asked to maximize the area, right? What is the maximum area that can be enclosed? So we want to try to figure out a function that represents the area. And we know that area is length times width. But the problem is we need a single variable in our function. And so we are going to use this relationship that we know that L plus 2W equals 300 to solve for L. If we subtract 2W from each side, we would get that L is equal to 300 minus 2W. And now the area can be represented as, well, L is 300 minus 2W times W. If we distribute, we get 300W minus 2W squared. So now we have a quadratic function. If you want to write it in standard form, it's negative 2W squared plus 300W. And so the maximum of this quadratic function occurs at the vertex. To find the vertex, we will let W equal negative B divided by 2A, right? That's the x value of the vertex. So negative 300 is our value of B, divided by 2 times negative 2, or negative 300 divided by negative 4, which is 75. So 75 represents the width of this rectangular yard. If you were asked what is the width that maximizes the area, that would be 75. If we had to find the length that maximizes the area, the length would be 300 minus 2 times 75, or 150 feet. But we are asked to find the maximum area that can be enclosed. So to find the maximum area, we can substitute the value of 75 in our function A to get negative 2 times 75 squared plus 300 times 75. And if you calculate that, you'll get 11,250, and that's in square feet. You could actually also multiply the 150 times 75 to get that value.